Hello everyone, my name is Aidan Barker and today I'll be presenting the research that I've been conducting with Dr. Derek Jokisch over the last semester, which we call the creation of scalable vector graphics images for use in internal dosimetry visualizations. To begin this presentation, first I'd like to go through a quick background of what internal dosimetry is for those who don't know. Basically, this involves the distribution of dose to the human body as a function of time from intake of radioactive material. There are three main modes by which this occurs, which is inhalation, ingestion, and absorption. From these, the radionuclides, which enter the body, navigate through a series of organs or tissues, and radioactive decay, because of this material, gives a dose to these target regions. And we know that different radionuclides, different materials, travel to different regions or sets of regions and affect the body a bit differently. So as of now, we've tried to, or many in the scientific community have tried to make diagrams that represent the amount of activity or dose in certain regions of the body or in the body as a whole. Some of these are animated even, and we'll see that here in a bit. But none have been able to show the actual human body anatomically correct and have animations which really give us a good visual idea of where the material travels and how fast it travels through the body. So that brings us to the goal of this research, which is to develop diagrams of the human body, which we use made of complex polygons of desired regions, and we export these as SVG files. Every portion of these diagrams are made of closed polygon SVGs, which can be assigned values using coupled linear ordinary differential equations, which give them the color and make them light up as a heat map. They represent the intensity of the activity or the dose to that target region. So essentially what we would like to do with this research is create a dose or activity heat map of the human body. Shown here are two diagrams which already exist, one animated and one not. But these are current models which represent the amount of activity or dose in the body over time or just in general. The one to the left, as you can see, has already started and it's animated and time is passing. And as time is passing, different amounts of activity due to intake occurs in different body parts. Each of these bars represent different source regions or target regions of the body, with the total being this black bar up here. This is due to the ingestion of radium-226 ingested by a 25-year-old. And so this gives a pretty good idea of how much activity is within the body due to this radionuclide and in what body parts they affect. But we still can't really see it in an anatomical perspective. Even less helpful, I guess, is the tree map diagram here, which gives us an idea of what inhaled plutonium-239 nitrate by a worker is going to most affect, which, as we can see, is the liver, lungs, marrow, and so on and so forth. But no animation doesn't really give us an idea of how the radionuclide is acting and moving through the body with time. So in this case, the animated racing bar chart helps us a lot with understanding where and at what point in time after intake the material gives an activity or dose. In the static one, not so much. So after seeing some of the current models which already exist and show us the amount of activity or dose within the body due to a radionuclide, it brings us to the creation of these more anatomically correct diagrams. And to do this, I used Adobe Illustrator. It seemed like the right choice considering that I can draw and trace objects at will, simplify paths, work with layers and name certain layers so that things are organized and I can understand what what all I create. And so right now I'll take you through some of the process by which I create these shapes and these diagrams. But it's also important to know what we're striving for and why we need them to be polygons. So here we kind of see one completed shape, which represents the heart. And it may be difficult to tell, but these are all anchor points which make up the outline of the shape. And between every anchor point is a straight line. It's very important it's a straight line, which makes this a complex polygon. All shapes that we create and export as SVGs must be polygons with straight lines, otherwise we have a difficult time assigning values and giving them color, which you will see later. So this is a requirement. It's just one of the things we have to obey, and we also have to verify that these are polygons by once they are completed, we open them in Notepad to ensure that the shape registers as it should, and list every anchor point, because these are the important contents which make up the shape itself. So the points are actually what help us later to assign color to the region within all of the anchor points. And so to create these shapes, the first part is taking an image from the internet. We take them for Google Images or vector image websites. And once we do this, we have a few options. We can image trace, which is a more accurate and intelligent way of doing it through Adobe Illustrator, or draw through straight line pen paths. But no matter what we do here, it requires that all lines are straight, everything is a polygon, so that we can move forward. Finally, we are brought here. And to the left, I have the diagrams that I've already made. We're going to have a few of them. This is the full body diagram, which includes the blood and kidneys, urinary bladder. We have a thin layer of adipose, we have skin, we have the brain, eyeballs, thyroid, etc. A lot of the more miscellaneous body parts, which are still important and are affected by radionuclides being ingested or inhaled or absorbed into the body. But we do separate this from the alimentary tract here, which is the digestive tract. We have the oral mucosa all the way down the esophagus into the stomach and intestines. And of course we keep this outline to understand where everything is relative to one another. And so once we can take these polygons and convert them over to an animation, we're able to assign values to every shape. And that's what you kind of see here. It's very exciting. This is iodine 131 ingestion, which once the timer starts back, you'll see it affects the esophagus and the mouth area first, because it is ingested into the stomach and then further down. And then later on, we see it affect the skin, the bone a bit, but the most intensity is here in the stomach. It's getting a little more red here. Eventually, I believe it affects the thyroid a lot. But this is what we've been working towards, and this is what we want to work even more on, to make these nice, pretty diagrams to really help understand where this material goes and what it affects as it makes its way into the body and poses a potential threat to humans. So this is what we have so far. This is still a work in progress. In the future, we want to create a respiratory diagram to the right of the alimentary tract, including the lungs and other respiratory target regions. But this is what we have for now. It's very promising and is working as intended. So thank you.